Hey guys, welcome back. In this video, I will mainly talk about one more concept to 5G, that is a massive MIMO. With the previous videos, I was mentioning that in 5G we had moved to millimeter waves to overcome certain challenges, and in millimeter waves we had seen that the frequency increased and hence the lambda decreased. So with this, what is the advantage? The advantage is that the antenna size is going to be very small. Okay, in the same area. Okay, let's say this is the area. In the same area, we can try to pack in more and more number of antennas with the decrease in the lambda, right? So why do we need that? So I was also mentioning that in case of analog beamforming, we had a requirement that we should have more number of antenna elements in order to form the beam in with narrow beam width, right? So let's say if we have a large number of antenna elements, then we can form the beam with narrow beam width, and also this beam will be able to transmit for a longer distance, and that would overcome one more challenge related to millimeter waves, that is to overcome the path loss, right? To overcome the path loss, now with the narrow beam we are able to travel for a longer distance. So considering all these things, what we can say is the requirement of a large number of antenna arrays is very well satisfied with the the lambda getting decreased, and also to perform the analog beamforming. So this is when we call this large number of antenna elements as massive MIMO. Okay. Earlier, in case of 4G, we add, I would say, 4 cross 4 or maximum 8 cross 8 antenna elements. So we used to call it as just a MIMO. But in case of 5G, we are exploring 32 cross 32 and even 64 cross 64 in the beginning. But moving forward, in case of very high frequency range, where very high center frequency of the order of 64 gigahertz, we would even like to go for, I would say, 512 cross 512 or 1024 cross 1024 and things like that. Okay, so now you got the clarity even with respect to the difference of what could be the antenna array size that we are using. So in all these cases, we call it as the massive MIMO. Okay. So what is the problem? Is there any problem with such a number of huge antenna elements? Yeah, one could be like to perform the analog beamforming, we need phase shifters across each and every antenna elements. The cost could little bit go high, and as well as even with the signal processing aspect, yeah, there would be slightly increase in the signal processing time. And moreover, if you are using more number of antenna elements, right? Then what is happening? You will get very narrow beam. Okay, so let's say you want to sweep the beam from minus 60 degree to plus 60 degree, then in this case you need to use large number of beams in order to sweep. Okay, whereas in case of if the beam width is a little bit wider, you can use less number of beams. For example, initially it could be just 8 beams to sweep the entire 60 degree to minus 60 degree, but moving forward we can have up to 64 beams also. Okay, so more number of beams will have more signal processing latency. um, those are the challenges here. Okay, so but with the massive MIMO, what are the advantage we can see? So massive MIMO, since we have large number of antenna elements, right? Okay, large number of antenna elements, um, we can go for transmitting more number of layers. Okay, it could be 8 layers or it could be even 16 layers. So basically you can go for more higher number of layers with respect to spatial multiplexing. So because of this spatial multiplexing, you will get higher data rate. Even you can think of having more UVs in multi-user MIMO concept, and hence more UVs in multi-user MIMO concept. All of them will experience high throughput or high data rate. So that is one advantage with respect to massive MIMO. The thing is that with the spatial multiplexing concept, with with the support of a more number of layers, so we can have a higher throughput or data rate. Okay, so but apart from that, I would also like to mention one more challenge, that is once we have large number of this is let's say large number of antenna elements, definitely your H will be like 64 cross 64. You have more number of channel taps to estimate, more number of channel elements we need to estimate. So that is one challenge with respect to massive MIMO. Okay, in case of many massive MIMO, channel estimation is a challenging aspect, and a lot of papers in IEEE have been explored to come up with the various channel estimation techniques, which can be performed in a much simpler way, still get the better quality. Okay, with this, I hope you got the complete clarity with the massive MIMO. What are the advantages? What are the challenges that we will get with the massive MIMO, and how what were the yeah, array size that we used in 4G and 5G and 6 like that. Thank you very much. Have a great day. Bye bye. Please stay tuned till then. See you, and please do subscribe to the channel.